So this question says 3 charges plus 4q plus 4q and minus q are placed on 3 points. One is minus a0, one is 0, 0, and this is plus a0. So if we think about the x-axis, that means this is the origin and the charges are placed along the x-axis. This is at the origin, this is at the distance of a, this is also at a distance of a, but on the other side. You should always draw a diagram like this. This will help us visualize the problem. If you observe the data, you will realize that this problem is similar to the earlier problem I had solved, the earlier video. See, there were charges of Q, and another charge was Q here. We had to find a condition where they are in equilibrium, and we got the answer as Q equal to minus capital Q by 4. This Q is equal to minus Q by 4. This was the answer, correct answer, which was option A. Compare this with that. See, this is minus, these are plus, so that minus is there. This is 4Q, this is only Q, so this condition is satisfied. Right? So in that question, they had told us this is at the midpoint. Here they have given us the coordinates, and from there we realize that this is at the midpoint. Understood? If you can relate a new question to the situation of an old question which you already know, you will find it simpler. So don't blindly go ahead to solve a problem. Just think a little. Have you encountered this situation before? And if yes, then what did you do? What was the approach there? Right? In the earlier question, we had to find a condition where they are in equilibrium. But in this particular question, out of the 4 options, option B says they are not in equilibrium. Other option says they are in equilibrium. So obviously, from the earlier knowledge, we know that they are in equilibrium. So option B is wrong. So we are left with 3 options now, A, C and D. Now here comes the concept of stable, unstable equilibrium. So for that reason, this problem is a level difficult than the earlier problem. Okay? Now, you must be knowing what is stable and unstable equilibrium. If you don't know, then watch my video on equilibrium, which I have already uploaded. Okay, so I'm not going to explain again what is stable equilibrium, what is unstable equilibrium while answering this question. Now let's proceed to solve this question. Say these are point charges, they are in equilibrium, that means net force is 0. So which formula to be used? Coulomb's law, formula number 1, which is valid for point charges. What is Coulomb's law? You will know that the force is equal to K into Q1 Q2 by R square R cap. This is the vector form. Okay, now let's consider the middle charge. This is in equilibrium. So if I displace it a little towards the right, so this distance will be less than this distance, right? So as per Coulomb's law, since this distance is decreased, so this force will be larger. That means this force of attraction on this will be larger than the force of attraction on this side. So that means if we displace this charge towards the right, it will have a net force on it towards this direction. It will tend to move further away from this equilibrium position, and that is the situation of unstable equilibrium. So that means here the equilibrium is unstable equilibrium. So if you see the options, this is option C. So the correct option for this problem is option C. See, we just solved it logically without doing any actual calculations. I have seen people using formulas here. This formula they will put it, they will make it x minus delta x, x plus delta x, things like that. No need of doing that. Because in the options they are not asking us numerical values. They are just asking us whether the equilibrium is stable or unstable or they are not in equilibrium. So without doing any calculations, by looking at the formula, by looking at the change in the distances, we realize that this force will be higher than this force once this is displaced. So this will go further away from the equilibrium position. So that means this equilibrium is unstable. Done.